Hello and welcome back, everyone. I really hope you enjoyed a short break and the interactive session before. Taking a look into the future throughout the future visioning and met new people, maybe even in our first networking round. Now we would like to invite you to dive into a selection of case studies that were conducted throughout the past 4 years, and we will also present some of the tools we developed here at the Textile Prototyping Lab. You will have the chance to choose and move between 2 panels, each having a different focus. The panel Boosting the Entrepreneurial Economy takes a look at 3 case studies focusing on the development of high-tech textiles in co-creation with professionals and companies from the industry. This panel is moderated by Marte Henschel, who is a serial entrepreneur and an ideational leader and sustainability expert in platform creation and responsible sourcing. She's specialized in co-creation formats and change processes and applying digital technologies to industries in flux. Currently, she works as a CEO at Sketch. Panel 2, Unlocking Talents, looks at the possibilities the TPL provides for young talents and creatives to develop their ideas in an environment which enables and supports their vision. The panel is moderated by Lucy Norris, who is an anthropologist exploring material culture, ecologies, design, and sustainability. She's also a guest professor of design and research and material culture at Weissensee Academy of Art. Both panels will conclude with a panel discussion where we again invite you to participate, get involved, and ask you questions to the panelists. Throughout the panels, we are sharing with you in the chat the websites of the speakers so that you can have a deeper look into their work after this event. How can you join? Again, you find the panels in the sessions area here in Hop-In, and they're accessible via the menu on the left-hand side. After the closing of the panels, we will have a pause and again invite you to use the time for the one-on-one networking and meet new people here under the networking section in Hop-In. And now, please enjoy the 2 panels Boosting the Entrepreneurial Economy and Unlocking Talents.
I think it's time that we now start our panels. Make sure that you're in the right one. This is panel number 2, Unlocking Talents, and welcome everybody. So if you're just joining, just quickly introduce myself. I'm Lucy Norris. I'm a guest professor of design research and material culture at Weissensee Kunsthochschule, Berlin. I'm a social anthropologist by training, and I've researched textiles as material culture. So that is as a sort of socially, culturally, and economically embedded materials. Technologies and processes, and that thinking about them as being sort of active in creating and recreating the worlds that we inhabit. And one of the questions I'm really interested in is how designers as co-actors are shaping these emerging worlds and what the values and visions are that they embody. Welcome Sarah and Laura. Fantastic to see you. Okay, our panel is now complete, which is a really good sign. So in this session, we're going to explore the achievements of the Textile Prototyping Lab as an open innovation research platform through some of the collaborative projects that bring together design students, researchers in industry and technical institutes, and practicing designers in studios. So we're going to explore 3 case studies based on partnerships designed to create the enabling structures needed to support collaborative research into highly technical textiles. And I'm looking forward to hearing their different perspectives as to how laboratories as creative spaces can really work. So with the goal of sort of combining very high levels of technical proficiency with design research methodologies and design aesthetics, these projects promise to open up questions as to what partners from different fields and different stages of their careers can learn from each other, and what makes a successful partnership, what future paths are opened up, and how might they be fruitfully explored. So as I said, we're going to have 3 case studies, and I'm going to introduce each one of them before they make their presentation. And the format will be that we'll have a general discussion at the end of the 3 case studies all together. But what I'd really like you to do is to start posting any questions that you have in the chat function. So my task as moderator is going to be keeping an eye on those questions, and then at the end asking our 3 presenters if they'd like to respond to them. So they could be directly to one of the presenters or more general questions that would apply perhaps to all of them. I think that there's also going to be a way that you can join us on screen and live with your questions. I'm just going to find out how that's going to work, but hopefully that's also going to be an option as well. So maybe just put in the chat if you'd like to be able to actually join us, or if you would just be happy for me to ask on your behalf. Okay, so our first presenter is Sarah Diaz-Rodriguez. Sarah is a textile designer, lecturer, and researcher, and she's also the founder of Studio Hilo. And her research focuses on the relationship between traditional textile technologies and innovative technologies. So she explores digital fabrication possibilities for textile manufacturing. She completed a master's in textile and surface design at Weissensee, and she's worked as a junior researcher and knitting lecturer in the Connected Textiles group at the Design Research Lab of the University of the Arts Berlin. From 2017 to 2021, she worked as an expert in electronic textiles in the Textile Prototyping Lab, and together with an interdisciplinary team, she analysed and improved textile manufacturing for smart materials. So today she's going to talk about the project Future Textiles, Digital Crafts, Weissensee Kunsthochschule Berlin. Welcome, Sarah.
Thank you very much for the introduction, Lucy. So exactly, I'm going to present our semester project, and now I'm going to share my screen. Oops. Do you see my screen? I guess, yes. Wonderful. So exactly, this is the panel 2. This is the overview of the 3 case studies that we are going to present. And this is my presentation, Future Textiles and Digital Crafts. I am very happy today to present our semester project, as I said, Future Textile Digital Crafts, from the Department of Textile and Surface Design. At the beginning of the semester, we wanted to focus on the semester and the idea of combining handcrafts and contemporary craftsmanships. Like, we wanted to melt this old tradition of textiles with fast prototyping methodologies. So to do so, at the beginning of the semester, we created together with the students a theme cloud, in which we explored together the topics of smart textiles, sustainability, craftsmanship, and digital fabrication. And we analyzed this topic by using specific design methods, like collaborative design processes or dynamic design process. So in these workshops, we had experts providing expertise in team building and also design thinking. But also we provided a theory reader in which we selected text related with the topics, but also in general with textile design. We invited during the first weeks, several guests and experts to our group, such as the designer Hela Jongerius or Ariana Moroder from the Italian textile lab Lotto Zero. We had also other experts from the field of design, textile design, design thinking, and also design research. They provide the students different perspectives of how textiles could be, and open up also new application fields for their projects. Together with this theoretical input, we also offer, or we started workshops on the prototyping machines in the lab, such as weaving with Karina and Katrin from Weissensee, also knitting with Teresa Kretsch from STFI, and of course 3D printing. After this process, or these workshops sessions, the students developed their own concepts and projects, and they could prototype their ideas in a big or big scale machines at the focus labs, at the industry partners. So they were able to prototype or create their projects in textiles with industrial machines, such as you see in the picture, big stall knitting machine, but also jacquard looms. The first project I'm going to present you, or one of the results of the semester project, is paper activity. From dynamic yarns to dynamic surfaces. Paper activity explores how paper yarn can be used to create activity within the textiles. Due to the hygroscopic quality of cellulose, paper yarn expands under the influence of moisture, as you see in the picture. Here you can see that this property is translated into a woven surface, with some areas of the textile acting as an activator. The change of form comes from an interplay of yarn properties and construction. The next project, Recode. How can we transform natural fiber waste into durable textiles that are emotionally engaging? Recode tackled the problem of textile waste. They reuse cellulose textile waste from the production process, and they spun the material into new yarn with a small amount of new fiber. Since the availability of waste is changing in quality, texture, and color, each yarn was unique. The yarns, or the resulted yarns, were knitted or woven into double-sided textiles, which includes a personalized text on one side and a pattern generated by the Recode software on the other side, making the textile a unique piece. Please check the website and the Recode name and make your own pattern. There is online and also open source. Matters of form, an explanation of unpredictable elements in control process. The project matter of form focuses on coincidences and unexpected deformations, which is exactly what the standardized industry process tried to avoid. In the project, these deformations are wanted and used as a design element. Depending on, or by changing the type of processing and machine settings, fabrics, and yarns, the results shows unexpected deformation and a unique aesthetic. T-yarn. A t-shirt is not just a t-shirt. This project claims that a t-shirt can be used as a raw material. The students created guidelines on how to cut a t-shirt in a specific way to create t-shirt yarns. They developed two different scenarios or paths for the project. The first path focuses on citizens and enthusiasts, that they can build and open source rope machines and create their own ropes made out of t-shirt yarns. Oops. The second path, or the second case study, is for professionals. They cut the yarns in a specific way that is possible to use in industrial machines, such as knitting machines or yakan loom machines, as you see in the picture. This specific project, or in this specific project, after the end of the semester, they founded a startup with the support of the Accelerator Design Farm, also from Kunsthochschule Berlin-Weißensee. If you want to know more about this project and discover their journey as a new young entrepreneurship, please don't miss at 2 the thematic session where the founder Bera will speak together with Anastasia Zargoni about the topic of her project, but also about urban textile manufacturing. Although we all suffered the COVID pandemic in 2020, we had the opportunity and the luck to show the semester projects at the Bauhaus Fest in Dessau in September 2020. The students had the possibility to network and exchange their ideas with the visitors, as you see in the pictures. So thank you very much for listening, and see you later.
Thank you very much, Sarah. It's great to see. Before we move on, just to remind all of you, in case some of you joined a little bit late, if you have any questions for any of the presenters, or perhaps general questions that could be asked to all of the presenters together at the end, do just post them in the chat. And I'm really looking forward to seeing that interaction between some of these very rich projects and our audience. Okay, so going to move on to our second presentation, which is going to be given by Camille Garbach. So Camille began his career by studying visual communication at the University of the Arts here in Berlin, where he was attracted by the creativity and artistic possibilities of electronics. So after finishing his diploma, he went on to do a second degree in electrical engineering at the Technical University here in Berlin. He then spent many years working as a student at the Fraunhofer Institute for Zuverlässigkeit und Mikrointegration, where he collaborated on the Textile Prototyping Lab's toolkit, with the aim of turning textile visions into real fabrics and garments. So Camille says that working in such collaborative partnerships that bring science and creativity together is ideal for him and allows him to draw on his experience from both worlds. So making electronics not only functional, but also aesthetically pleasing. So he's now working as an electrical engineer at the Technical University here in Berlin. But today he's going to talk to us about the eTextiles toolkit and the project Touch Tomorrow. Okay, over to you, Camille.
Yeah, thank you very much for your kind introduction. Let me just start my presentation here. Can you all see it? I might turn off my webcam because I have like some bad connections over here at home. Can you see it?
Yes, it's fine. I can see it. Thank you.
So yeah, before we jump right into the toolkit, I would like to talk a little bit about our main motivation for creating such a new system. Then we will have a look at the TPL toolkit itself, what it makes different, and at the end, I would like to show you one of my favorite projects where we have been using it. So that's what I call the dark ages. Before 2005, there have been no Arduinos. And actually what you can see here is the very first Arduino made by Massimo Banzi. And as you can imagine, back then it wasn't very easy to make electronic projects, especially at home. You had to spend a lot of time to learn and create new things. And it was more like for people with like a science background, from computer science and stuff. But this little board, or at least what came after the prototype, really changed a lot. And in the next years, not only the hardware has further developed, but also the software and the community. Everyone interested in electronics could just buy an Arduino, connect an LED, run a sketch, and yep, it just blinks. And I guess most of us had already seen or made this blink example themselves. So many people became interested in electronics, people from different fields with different backgrounds. So companies started to develop systems that are specialized for the needs of specific groups of people. Here you see just some of those boards that have been developed. We have boards for robotics, for game development, for communication like Bluetooth, and most important for us, because also many textile and fashion designers started to experiment with the integration of electronics into their projects. Boards have been developed that have been optimized to be used with textiles. I think a very famous board is the Flora by Adafruit from 2012, so it's almost 10 years old by now. They thought about a better integration of the electronics into textile-based projects. So as you can see in the picture on the right, they have used, you can use conductive yarn to interconnect the individual modules. And looking at the layout, we see all those pads on the outer circle of the boards with holes in it, so you can easily embroider the yarn to it like you would do with a button. So this was more and a better integration into textiles by using these modules. And this was really our starting point back then when TPL started and the development of the toolkit. Because the concept from the Flora was good and still is. But we noticed that it's still hard to take your prototype and idea to the next level. Usually you will end up having a lot of components on your textile all over the place. You have to take care of electric shorts. And finally, the whole system had to be redesigned to make something like a final product out of it. So that's where we started. We had a lot of workshops. We talked to experts, to fashion designers, textile designers, because those were the people that really have used those electronic toolkits before, and they do know best what have worked in their project and what have not. So while having these workshops, discussions, we started developing our own toolkit set. We had prototypes, we had a lot of revisions, we have been testing them, we talked back to the experts. So we really tried to find out what's a good toolkit that can be easily used in textile-based projects and fulfill all the needs that people are seeking. So, and I guess the next big part of this whole development is also the validation. That's where we do have really real projects where we get feedback. We get to know what haven't worked for now, so we can improve it. So it's always a circle, and it was very important in this TPL context that from the very beginning we try to work and talk with people that will use our product at the end to make it better from the very beginning. So that's why we developed over the years the TPL toolkit. Here you can see a little picture from the TPL pop-up opening event. I will explain those modules in more detail, but here it's like little kit you could maybe buy someday, where you could start making prototypes and yeah, in a very easy way, like you're already familiar with when using something like the Arduino. So to give first like an overall overview, the toolkit consists of three main parts. We have control and communication units, we have sensors, and we have feedback and actuators. For the control and communication part, we have modules that are very small. We have extended modules with, for example, Bluetooth connectivity, and we have a max board where you can also add further sensors, external hardware, and so on. We have a bunch of sensors. Those have been already developed after we have talked to people, what are their needs, what they would like to integrate in their projects. So we have temperature and air pressure sensors, and we have sensors for motion tracking, so inertial sensors like an accelerator, a gyroscope, and magnetometer. And we have ADC modules where you could simply like connect all kinds of different analog sensors to measure data, and again, do some feedback like RGB LEDs or vibration motors, and there are even more to come as we do further projects and people tell us what they need, so we can still and easy implement them to our toolkit. So let's go a little bit into more detail. Here you can see the very first little TPL control module on the right. It's the TPL Mini. It's quite small. The whole system is quite modular. We have a communication bus, so the modules communicate with each other with only 4 wires. And what's very important in this whole toolkit is the multiple way integration. So you can use it in different ways, but that's what we will talk in a minute about. So we have, like I said, the sensors, and because we don't want the people to start over with all what they have learned by using, for example, an Arduino or the Flora, everything is integrated in the Arduino IDE, so you can use the same software, you can use the same libraries. And we also provide libraries for our specific modules. So it's quite a simple start to the world of electronics as well, but in this case also in e-textile based projects. So here's a picture of the Max module. So it's a little bit bigger, but it provides additional GPIOs at the end. It looks familiar to you when you have worked with something like the Flora. In this case, we have also integrated an onboard motion tracking sensor and Bluetooth as well. So you will not need any further hardware if you just want to have like some motion capturing activities in your project. So let's talk about a very important part of the whole toolkit, and this was the integration. Because when we, as I said, using something like the Flora, you always end up with a very early prototype, which is kind of messy, and it's quite hard to transfer what you have built to the next level. That it is more like an industrial product out of it. So we developed a concept from the very beginning where we thought how we can make this hardware being transferred quite easily into industrial integration. So here you can see the main concept. So we have like this 2 parts in each module. We have the module core itself, and we have those outer interconnections, in this case for embroidery, for example. And as you can see on the left picture, this would be totally be embroidered by hand on textile. But the main idea was how we can use the same hardware without changing it, without changing the software, and then integrate it in a way that is more reliable, that is more industrial. To give you some examples, first we have like this very simple integration of our module. This is just a test. It's hand embroidered. Conductive yarn have been used, like you know it from the Flora again. And you can just very fast do rapid prototyping just to test your system. Is it working? Do I have connected the right things to it? Is my sensor working? But then in the next step, we wanted to give the opportunity to use the same hardware, but shrink it down to an even smaller size and integrate it with other technologies. So What we developed here is something we developed at the Fraunhofer IZM, and it's an e-textile bonder. It's a bonding technology where we are able to first embroider conductive threads on any kind of fabric or textile, like you see here. Those are the 4 wires you see on the fabric. And then we can, with the e-textile bonder, we can use the same TPL toolkit modules. But in this case, we just removed the outer connection points because we don't need them anymore. But we can use the e-textile bonder to bond those on the fabric, so we get a very reliable interconnection between our signal and the modules itself. So this is, like I said, the main idea of the TPL, that once you just finished your prototype, once you are you have validated that it's working, it's really easy to go on the next step. So you can take the same module, you don't have to buy or create new hardware, but you can just make it more like a final product, better looking, compact product, just by changing how the integration technology. Here's another example for the bonding process. In this case, we do have a belt where this conductive threads are like integrated in the belt, and there are like parts on the belt where you can see them, and on those open conductive threads, we can use our e-textile bonder to take a TPL module, like for example here, this is an RGB LED module, and bond it on the belt. So we really have a compact, good integrated interconnection between the electronics and the medium, in this case, a belt. So here's another project by Malu Bema, where we have also used this technology. Also, she first used, and I couldn't just find a picture, but she first used our modules in a very manually handmade way by just not removing the outer connection lines pads, and she was just experimenting with LEDs, using traditional wires, soldering them together. And after we just could say that the system was working, we could use our embroidering machine, embroider all those conductive wires on it, and then in the last process, we put the modules on it with a bonder. So to talk a little bit about our vision for the TPL platform or toolkit, because we see it as a platform. I have now talked about the hardware and the software, but it's really about the community and the TPL pop-up lab. So that's how we also started. We have talked to people who actually are using those things, and that's still what we're trying to achieve, to make to provide the system that grows over time by adding more and more modules. For example, if we notice, okay, there is a fashion designer who has this idea, we didn't have thought about it before, so we talk to him, he talks to us, and we can extend the TPL toolkit. And besides the hardware, the software as well is like developed in a way that is also very, very easy to use, because all the modules have like a fixed address. So you can just connect them together and you will get some kind of output on your computer, which tells you, okay, I have found a temperature sensor, I have found an LED, everything seems fine, what you would like to do. But that's something we are still working on. We are now have like the hardware ready to go, tested and using it in projects. And now it's all about building up a community with tutorials, workshops and stuff. And that's, I guess that's what the TPL pop-up is all about, and the TPL in general. So I would like to give you some insights to one of my favorite projects. It's the Touch Tomorrow by the Hans Riegel Stiftung. It's actually really a truck that is traveling through Germany, visiting schools. And in the truck, we have different areas, and on each area, a different technology is presented. And the Touch Tomorrow and Hans Riegel Stiftung came to us, TPL, and asked if we could provide a little exhibition a little demonstrator prototype for their area Smart Textiles. And that's when Sarah and me have been working out the concept. So we have been thinking about, okay, we have these modules, what we can do with it. It will be used by children who are like interactivity. So we thought of a project and the concept where we would like to create a jacket where we have a lot of LEDs on the back of the jacket and on the arms, and we have our IMU sensors, so for motion tracking, which are part of the TPL toolkit. And then by raising your hand on the left and right side, you could first shaking it to change color and then put it up and down. You could kind of let the color flow in the back where it is mixing up. I think it's better if I just show you some pictures. First of all, here you can see how the electronics look like. You see the RGB LED modules on the back of the jacket, where we have been using the embroidery machine to place those conductive threads, and then we have bonded the RGB LED modules on it. Here you can see a close-up. We also have, as you can see on the left bottom side, did some soldering, which is also possible if you don't, as I said, remove those connection pads. And the third part we have in the arms, we have used one of those belts where we just have bonded a lot of those RGB LEDs on it. And at the very end, we have this final jacket with integrated LEDs. Here you can see the arms and the back. There's the logo of the Touch Tomorrow. On the back, and also there is a very cool video you can watch on YouTube. Here's the short URL. I will put it in the chat later. So we did a little video shoot where a dancer was wearing our jacket and she moved to the music and mixed colors on the run. I do have a little video here. I hope it's working. It's just a few seconds. Yeah, here you can see how those, in this case, like the green color was flowing down to the back of the jacket, and it turned out green at the end. So actually, this is my little overview of the TPL toolkit. I guess if there are any questions, we will discuss them later. But first, thank you for listening, and
Wow, Camille, thank you so much. That was really exciting. And I think it would be great if you could post that link to YouTube to the video in the chat, because I'm sure there'd be lots of people who would like to follow up on that later. Okay, and just a reminder, I think I was also, just to apologize, putting a couple of things in the chat for the event, which is not quite the same as the chat for this session. So just to repeat, do put any questions here in this chat for the session for any of the speakers. Okay, cool. Thanks again, Camille. So now we can move on to our third presenters of their case study. And I'd like to introduce Sarah Myers and Laura Vogtland, who are co-founders of the design studio Myers Vogtland. So Myers Vogtland is a Berlin-based design studio working in the field of textile product and interior design. Sarah and Laura met while studying textile and surface design at Weissensee Kunsthochschule Berlin and completed their masters in material utopias at the Sandberg Institute in Amsterdam. Their experimental design practice is guided by a hands-on approach and a deep interest in color, texture, and materiality. They specifically use color as a medium to underline material properties and make the steps of the production process visible. And since 2012, Sarah and Laura have also been working with Hello Jongerius, and I think you were involved in the recent exhibition at the Gropius Bau as well. I'm sure many of the people in the audience will have visited it or read about it if they weren't based in Berlin. So I'm really pleased to welcome you, and today we're going to talk about your project Vivid Curtain.
Yeah, thank you, Lucy, for having us. I will try to share our screen. Wait. Okay, so is it working? Yes. Okay, so yeah, Lucy introduced us already. We are Thüringen-Vogtland. I will show you some examples of our work, what we work, and yeah, it's on the right part you see our freelance work for Jongerius Lab. We worked a lot on the exhibition in Gropiusbau, mostly in the textile field, and lately on three-dimensional weaving. We are textile designers, but we also work in ceramics, mostly in porcelain, but that's not important today. We are fascinated by natural dyes, and we have one product, the blankets that are a product that you can buy. They are naturally dyed, and we did also a lot of research on how you can use the city as a dyer's garden. And we like the natural pigments because they not only create one single color, but they often have a cocktail of pigments. And
yeah, and we also believe that they are more sustainable, the natural dyes, because you use less chemicals. What's often seen as a negative aspect of the natural dyes is their low light fastness. So we've also done some research ourselves, like put up some textiles that were dyed with elder tree parts, like some with the berries and some with the leaves. And after 2 or 3 weeks, you can already see that the color is fading. In industry, the light fastness of textile is measured with the blue wool scale, 1 being the lowest possible light fastness and 8 being the highest. So most natural dyes have a light fastness that reaches maximum 4 or 5 in this scale, and most industrial dyes have a light fastness that is more like on 7. So we've been thinking about how to turn this negative aspect into a positive quality, or quality that you actually want. And we thought of combining naturally and synthetically dyed yarns in one textile, so that slowly over time a pattern will reveal. And with this idea, we went first to the Textile Prototyping Lab in 2019 and just did this 3-day small masterclass. It was only 3 days, where we wove some samples, some monochrome samples with these 2 yarn types, and then we sent them we got them exposed, and we already saw some results, how the pattern could fade over time. And yeah, we got really excited about this idea and wanted to implement it into a product. So we thought of the vivid curtain, which which is a monochrome curtain that will change over time, and we start to reveal a pattern. Because the naturally dyed yarns are going to fade over time, and the synthetically dyed yarns will remain in the same color. We also really liked that the idea of having a product where the aging process is designed into the product already, and also that the owner and the product will grow old together over time. This project was funded or was supported by the Worth Partnership Project. This is a funding where you team up with 2 partners, and our 2 partners were Färberei Fritsch. This is a dyeing company in Vienna, and they already, since 15 years, they also offer a naturally dyed yarn palette. Before, we always dyed everything ourselves. All the wool that we use in our blankets, for example, we dyed in our studio. So this time we really wanted to work with a professional dyeing company and buy dyed yarns. And those are one of the few left in Europe that still do natural dyes. And then the second company was a weaving mill in the south of Bavaria, no, north of Bavaria. They have like really industrial jacquard machines, so we wanted to work in a very high-tech textile field and have a complex jacquard pattern in our curtain. Those were some of the pigments or some of the colors that we selected from Färberei Fritsch, and we had them exposed in the light fastness test. And here you can see the colors before and after exposure. And you can see also that their light fastness ranges from 1 to 5. Like the rose color has the lowest light fastness, only 1 to 2. And for example, the black color in the bottom has the light fastness of 4, or also the top of 4 to 5. These light fastness tests are it's called the ISO 105B02, and it's like done with a xenon lamp, and it resembles 105 hours of exposure with the xenon lamp. What this really means in reality and in different parts of the world, yeah, nobody could actually tell us, but this is the test that is used in industry to determine light fastness. So next.
Yeah. So in our process, we chose 3 colors of different light fastness. So the rose, the left one, has a very low light fastness, the green one, the middle, and the dark blue, a better light fastness. And then we got these 3 colors. We got material dyed one time a natural dye process, one time a synthetically dyed process, so that we would have the same color in 2 materials. Then we actually applied for a longer masterclass at the TPL and got accepted, but the timing was bad because after we installed all the threads on the loom on the TC2, Corona came, and due to the pandemic, we were not able at that moment to work at the TPL. So we had to improvise a little bit, and we then used screen printing to work out some first patterns and to continue working because that was easy in the pandemic. And then we sampled directly at Rohleder. And then we created 3 prototypes in 3 different colors, also to create a little range, to have a light curtain and a dark curtain, and to understand or imitate this quite complex process of fading. We also tried to weave a simulation. So this, like, wait, I go back, the dark blue, if it's completely faded, it would actually look like this. That's not completely true, because every curtain will probably create a unique painting of light according to the place where it is hung, to the hours of sun, and also the shape of the window. We leave a trace on the textile.
Yes, and because these light.
Yeah, so we only had these small tests before that have been done, and then we were looking for a possibility to have bigger tests made, and it was a challenge, but we found a company specialized in it. It's Atlas, and they have an exposure site in Arizona where they expose textiles in 45-degree angle to the sun, and it was perfect for us. So we sent samples there, and now I can show you the difference. So on the left side you see the before the exposure, and right side is after. So these textiles were exposed exactly 2 months to the sun in the desert. So that was quite interesting for us. But then,
yes, now it's my turn. So, but these were still tests like in extreme conditions, we thought. So we also found 3 places in Berlin where we hung our 3 prototypes. One is a private flat in Schöneberg where we hung the dark blue one. Then we went to Lobeblock in Wedding to hang the green one. And then our studio colleague Adrianus has the rose one in his studio. And just to see like what effects do like different usage and also different window shapes have on the pattern, and how long does it actually take until you start to see something. For example, now we know that after one summer you only softly see some traces of sunlight. So this is probably a process that will take several years.
in Berlin.
In Arizona 2 months, but here a bit longer. So then actually this October, we finally were able to go to the TPL to do our one month masterclass. And since we had already developed the curtain and already developed the textile, we had to find a new purpose for the masterclass. And we decided that we want to weave a sun umbrella. So we wove like 8 triangles now on the loom, which we will assemble into an umbrella, also to have like a more playful product, and also something that we can just take with us to holiday, and then the sun does the work for us and we don't have to send everything to Arizona to do further testing. The umbrella will, it's going to be half green and half pink in the beginning, and then on one side it's going to fade, and on the other one we wove more the stable yarns, the synthetic yarns. So let's see, but we only finished this last week actually at the TPL, and we haven't assembled the umbrella yet. This is still in process, this project. Yeah, well, thank you TPL for having us there. It was really nice to finally weave on the loom, and also thank you for letting us introduce our work here.
Okay.
Cool. Thank you both very much. And everything worked. And yeah, I really look forward to seeing that assembled into our umbrella. I kind of think that would be a sort of iconic thing to take with you on holiday as you go around. That looks very cool. Okay. So we now have a few minutes for a discussion round. And we do, so everybody's still here. You can turn on your mics when you want to. We don't yet have any questions in the chat, but I do encourage everybody to type away, ask whatever you'd like to ask. I think there were 3 very sort of provocative presentations, and so I see myself as somebody very much from outside this world. So I've got all sorts of interesting questions buzzing around in my head about what these projects could mean, what they could do, where they might go. But I'm sure many of you listening and watching also have questions. So I'm happy to kick off, maybe coming back to you, Sarah Diaz, with your presentation. So I was really lucky enough to come along to some of the presentations. I wasn't so involved in the whole project, but I did come along to see some of the stages, from kind of initial ideas to a sort of interim presentation to seeing the final projects. And there was sort of, I mean, it was for me an amazing project. And I was wondering if first maybe you'd like to say a little bit more about the conceptualization of the whole project, this sort of bringing together very traditional technologies with the opportunity to use digital, very high level digital technologies. Would you maybe say something a bit more about that?
Yes. Actually, the idea behind the semester project, or actually the way we wanted to do it, it was the first intention was actually to test our TPL system. So how can we connect the fast prototyping within the central TPL with the focused TPL partners? So how can we scale up such a crazy ideas or more innovative ideas coming from designers, but scaling them up in the industry or in industrial machines. And this process, maybe for some of the audience, maybe sounds like irrelevant or easy to do it, but it's very tricky to scale up. Like you have to translate one language, which is prototyping, to industrial machines. And this was actually the motivation of the project. And for us, also from the educational point of view, we wanted also to encourage the students to work together, to work in teams, to share ideas and not to hide their ideas and projects. Because in real life, after the university, as you all know, you always work in teams. You always collaborate with industrial partners, with graphic designers, with many different people. So we wanted to engage them to start to work together and be able to develop ideas together. So this was actually one of our motivations, especially from Essie and I. And at the end, we were very happy, and from my opinion, was a very successful project or projects, so that at the end we have actually a group that founded a startup with the idea and the concept. So I guess they also enjoyed it a lot. Speak a lot, sorry.
Yeah, I mean, I have to say that I was pretty astonished by the range of projects. So there's perhaps a secondary question was in terms of sort of TPL, was the sort of enormous ambition that you had to be able to enable students to work on everything from 3D printing to, highly technical jacquard looms to, very simple rope making machines, and projects that kind of came up with I suppose as teachers and as intermediaries and as sort of negotiators of all these relationships, how you managed it actually. It's just actually the kind of concept of TPL and a semester project, which is quite often, it allows students to come up with their own ideas and their own work, but there are kind of boundaries to it. So how you sort of felt that you were able to set boundaries at the same time as allowing people to explore their different ideas?
Very good question. Actually, the core idea of TPL is actually to remove these boundaries. So because textile is like an in-between product, it can be anything. You can apply it in like a micro level in medicine, but also in macro level in buildings. So it's very wide and open. It's not only focused on fashion or interior, it can be anything. Also in cars, you find textiles and planes. So it's very tricky to understand the application field and actually to remove the boundaries, but keep the projects realistic. But this is the USP, like the core of TPL, that we are able to apply our knowledge in new fields and actually expand these fields to maybe new applications. So this is exactly what we wanted to teach the students. So think beyond your standard application fields and try to find new ways that fits to you or to your design aesthetics or applications. So think beyond.
Cool. Yeah, I mean, I really recommend everyone to follow up some of the links that are in the chat for the T-Yarn and some of the other projects that you showed, because they were really incredibly diverse and showed just an amazing array of creativity that people had come up with when those partnerships start working. Yeah. So so on my screen, you're not next to Camille, but you were also involved with Camille in the jacket project. So if I kind of sort of move on to talking about Camille, then perhaps both of you, of course the question was like, how did the kids in that Touch Tomorrow truck going around, how did they react to that jacket? Camille, you're still on mute.
Yeah, actually, I haven't been there to see it in person, but yeah, we were told that they were quite curious about the technology behind the whole jacket. So it really is an educational project to make the people, especially the children, ask questions about how something like this works, and that was the aim of the whole project, I guess, to make something that first looks kind of like cool. So it's they are interested in it. So it's not like just like a boring black box that's like doing something and blinking a bit, but something they can really touch, put on, and really interact with it. And then it began then to start just to ask, so how is it working? What's the technology behind it? And that's, I guess, the aim of something like this. So to combine good technologies with something that is also like interesting and aesthetic. So people, just even people that are not like into technology, really want to know how it works. And as far as I was told, there was a really good response to the project by the people, children in this case.
So, I mean, the next question is, I think it's really interesting the way you built up your talk. So I've lived most of my life in the dark ages, the pre-2005 bit. So for me, it's really interesting to see the very sort of logical, methodological way that you built up the kind of case for how you would kind of expand, you would prototype, you would get the feedback, you would, you know, and I guess the sort of the step is, once you introduce those, you show people, touch tomorrow, you show people in that kind of setting, how does it then kind of leave, again, I suppose this is about boundaries, the boundaries of your imaginations as to what this might be able to do, and become something that kind of whole other groups of users that you haven't even imagined might be able to feed back into the process. That's the kind of, I guess, the big leap then from this kind of prototyping, the small toolkit, to seeing where it might go outside of your control and your imaginations. Do you have any plans yet for how it might grow?
So first we would like to put it out there, so people can really like hopefully buy a kit like this and really use it, because that's how we will get our feedback. So really having people using the modules, noticing maybe issues or something, and it's like with all new technologies, you have something, but from the beginning you can't even imagine what is possible with a new tool or something, and then people that are more creative than you are starting to combine things in a totally different way. You haven't thought about it before, and then you have something that is even better with the same system, and you are, okay, wow, cool, we can maybe again improve it or build it, put it in there, and that's how things usually work. So you can write a little piece of code and have like some fragments and give it out to people, and then they will combine it in ways you haven't imagined, and then you have a big new thing out there. And I guess with something like this toolkit or other systems, that's how I said, that's how the all maker scene have started, like 15 years ago. People did not have the knowledge or the time to get into electronics, but then there was like this little thing you could just buy for not much money and start experimenting around with it, and then with time the interest grew, and I guess many people became even like scientists or something, because they had the chance to play with an Arduino, for example. Like people had become architects because they had Lego when they have been young, and building blocks. And that's I guess the most important part, to have like this little pieces where and give them to people, and with their creativity, they put them together in different ways, and then it just grows, and we will be there hopefully to improve it by having all those different kind of projects that will come up.
Cool.
And may I add something to this wonderful statement from Camille? That actually the core, or the idea also, the Baukasten system and also TPL, is create knowledge through sharing. So it's also the mindset of or the idea behind open source. So, we would like to, the idea is to democratize knowledge and technology, so everyone has access to this technology. So everyone could be a scientist or a designer, or to open this, not only black boxes in electronics, but also in textiles. So open up these black boxes and share with everyone.
Yeah, I really look forward to seeing where it goes and how you're going to get the feedback and maybe upload that onto your own TPL Toolkit YouTube channel. See what people do with it would be really cool. Yeah, it would be really interesting. So, I mean, do jump in if you've got questions for each other. I meant to say that as well. So, I mean, it's not like I'm kind of in charge and going around in a circle. But I did want to then come on to talking to you about the vivid curtain, Sarah and Laura, and then maybe we'd see if there's some kind of common themes that come up. I mean, I really love your work looking at that. I mean, I've been meaning to find out more about you actually for quite a long time, because I'm interested in this idea of the sort of city as a source of colour and how one can sort of extract colour naturally from the city, and how people view their sort of environment and their surroundings in terms of, you know, what's visible and then what's invisible, and how that can then kind of suffuse the materials and objects that we live in. So I think that's just a really interesting idea. But thinking about your vivid curtain, I really love that. I mean, I also really like the idea that it's very place-based, because I've spent time living in India, and I know that if you wear natural dyes, you can literally, the shoulders and the front bits of your clothing are all sort of faded, and the bits where your long hair is are not. I mean, you sort of walk around and your body and skin becomes a kind of sort of interactive tool for the kind of sunlight that you're experiencing. So I love the fact that in different places, in Berlin, for example, it has a very different, more subtle effect. But I guess one of the questions is this, then, if you're asking people to sort of reflect on that relationship to change, to fading, to why we have these sort of standards of fastness, then can you see a way that you might be able to move towards doing that, where you're not mixing the synthetic and the natural, and you're experimenting with different kinds of natural dyes in order to perhaps take it another step further?
Yeah, I think we have been thinking about that a lot, actually, like, because before we've been only working with natural dyes, and then we were also a bit skeptical, should we introduce should we introduce a product that is half synthetically dyed? But also, I mean, what we ask ourselves often, what is really more sustainable? And it really depends on what types of criteria you take. For example, if you dye naturally, you use renewable resources, because plants can just grow again, but you also use a lot of water and a lot of energy in order to color the wool, and you can also only dye natural material. And some of the, like, for example, our synthetic yarn was produced in Germany, also dyed in Germany, and some of these dye circuits have a really, really low water and energy consumptions, but you use non-renewable resources, because all the fiber and the dye is based on petroleum. So we are also sometimes a bit unsure what is really more sustainable, and also which criteria to take. And so we really wanted to create a discussion piece that you start to talk about this.
Because we also noticed, like, with our blankets that are all naturally dyed, everybody thinks like, ooh, naturally dyed, good, green, we can buy it, we can consume. And actually, we were feeling bad about that. So we really wanted to create a discussion piece where we think also what is good, but
what are the sustainable processes, and how, because not everything natural is automatically good for our environment.
And especially, like, now going back to our blankets, woolen blankets, we always dye the wool in our studio using a big pot on a flame. Like, it's not the most energy efficient way of dyeing, but people still hear naturally dyes and they see green. Okay, good. So
And also some of the mordants that you use to open the fibers for natural dyes are actually one of the most chemical chemics that we have in the dyeing industry. Like also a lot of natural how you say substances are actually toxic.
Yeah.
So it's that's why we really decided to combine both in one piece to create this, to open up this discussion.
Yeah, it's
also among other textile designers and experts.
It's also, I think, our way to live with all this knowledge about this bad industry, and to still find a way to.
Yeah.
And also, it will, I think, never become a product for a huge amount of people, because it's very difficult for people to buy something and not knowing how it will look in a certain amount of time.
But I really love that as a provocation. And also, of course, behind your sort of statement, well, you know, it encourages people to buy loads more. You're also, I think this other aspect is your designers running a studio, obviously wanting to make a living and do the right thing. So I think I really like the way that all of those, I mean, they don't have to be in conflict, but they're obviously all intertwined, how one makes decisions based on that. And actually to continue posing the question is often the most interesting thing to do, but you still want to be able to survive while you're doing it. So I think that curtain is a really interesting piece and an interesting way in to have people think about time and durability and their emotional relationships with objects. But also this perception, as you say, that many people have, that synthetic dyeing is, you know, toxic and natural dyeing is not, and many of us don't really know the detail.
I would like to add one thing that I think it's really beautiful in your project, which is time as a design aspect. Through time, you let the piece live specific years, and then the design comes up, and this is a very beautiful aspect. Very nice.
Thank you. Yeah, we also talk about it like that it ripens like a wine, that you could
it was a bit funny to present this really low-tech project after your super high-tech project because it's actually so simple in the technique, but
But actually, I mean, on a really basic level, even with the flora that Camille showed us, I mean, this nature and these shapes, they're finding their way in because of all the things. The easiest thing to do is to get a sort of flower shape with these little petals and then embroider them on. You know, we learn it as kids. And then, you know, I think it's quite interesting how some of these motifs come through the very high tech and, as you say, kind of all these, and jacquard weaving and all these different kinds of ways of engaging with technology.
And sometimes I wonder, because I was working many years in the smart textiles field, in e-textile, and I also wonder what is more smart? A piece that is just react by themselves without energy or power and just transform from itself, or use a battery and embroider circuits. That I think there is no concurrence there. There's like a both really, or like two aspects of smart materials or smart textiles. So,
I think that is it's a really, I can't believe it, but I actually see we're on 1:30 now already. And I think we're supposed to be joining network sessions at 1:30, and I feel like we've only just got started in what could be a really interesting conversation about smart textiles. So I think to allow everybody to go to the networking sessions, and then hopefully if anybody has any more questions, you might like to hop in and ask our presenters personally. But thank you, everybody, for your fantastic presentations. Everything worked super well, really interesting. And thank you to all of you in the audience. Okay.
Thank you, Lucy.
Thank you very much.
Bye.